Hi all, welcome to part 8 of the video lecture on registers. So far we discussed register and many of its variation. Okay, so variation means a standard variation we discussed like the shift register and for category of that like serial in, serial out, serial in, parallel in, serial out and parallel out. Now some other extra variations we will see. So depending on the way in which various stages are connected, stage is nothing but a flip-flop. How these flip-flops are connected in a register, depending on that there can be various shift registers, right? So further variations, so the four things we discussed is standard variations. Now it is something they are having some special purposes, right? One is ring counter. Not only ring counter, any counter is basically variation of register only, but ring counter is something that is worked purely based on that shifting operation. So it's a variation, a nice variation of shift register. Okay, anyway, we will see what is this ring counter. It's there explicitly given in your syllabus also. And another variation is like a twisted ring counter or Johnson counter. Once you understand ring counter, it will be easy for you to understand this Johnson counter. And in this video we will see what is this bidirectional shift register, a small variation of the basic shift register circuit we saw. So as the name says, it can shift in both direction, bidirectional. It's bidirectional, right? It can shift right and left. Now there is something called a universal shift register. As the name suggests, it can do everything, universally acceptable, like all types of operation we saw so far could be done by a single register. If you can think about it, that is what we call as a universal shift register. And another interesting variation that finds many applications, these things are actually not explicitly given in your syllabus. They are simply saying register and some names are highlighted, but if you are writing that gate exam everywhere, you will always see a question that is being coming from this linear feedback shift register. So I am just introducing. If somebody is not interested, like in exam point of view, somebody is studying, you can skip the further videos, and that is what I think. And ring counter, Johnson counter, that is there in your syllabus, that you can watch. The other thing, just for the information coverage as well as so for if you are applying some good exams, like any competitive exam, that time most of the questions I saw from this linear feedback shift register. In a university exam also they can ask you, but it's not directly given in the syllabus. But anyway, I will be covering it in the subsequent video. From the register point of view, the basic understanding, it's enough to watch video up to 7, but these things will be for advanced understanding. In ring counter and twisted ring counter, again by default it is expected, right? So let's start with bidirectional shift register. It's just a small variation of the register circuit we saw already. We should be able to shift the data in both direction, towards right as well as towards left, right? Now at any time you can decide whether you want to shift towards left or right. So again there is the role of the control input, right? So then only two things you want to do, right? So that multiplexer will be there, and what kind of movement you want, accordingly you have to give the multiplexer input, and the select line of the multiplexer is nothing but something like a L, where is it? This one, right? L bar R bar. I hope you can understand what does it mean by this time. So we saw many things like this. See, whenever this line is having a value 1, that means shift left. L stands for left. Okay. Whenever it is having a value 0, that means shift right. Okay. So this is how I want. If you want, you can take it like a L bar or R, like that also, but this is how the figure which I'm going to show now it's implemented. And the other thing is also fine. Anyway, one input, just a single control line, right? If I am giving 0, one thing should happen. When I am giving 1, another thing should happen. So here if I am giving a value 0, right shift will happen. If I am giving a value of 1, left shift will happen, like load and shift bar. Hope you remember, right? So that's about, based on the control input, the shift register works in either the shift right or the shift left mode. So the multiplexers are used to feed the appropriate signals to the D inputs of the flip-flop, and the control line L bar R bar selects the multiplexer input, determine whether to shift left or right. Yeah. So this diagram clearly explains what we want. So you know the basic shift right circuit, right? So what you have to do, the serial input you will be given to the first, so here I am having this multiplexer extra. Okay, so listen it carefully, and the select line of the multiplexer is our L bar R bar. Okay, and whenever you are giving a value of 0 to it, that this first input will be selected. So this kind of a bridging will happen. Okay, this will come in the output. Whenever I am giving a value of 1, this will be connected to the output. So this is how it is fundamentally working, right? So now let's assume that I am giving a value of 0 to this, so that R bar, this right shift is supposed to happen. Let's see whether it is doing this right shift. Whenever I'm giving a value of 0, this kind of a bridging will happen and it will feed the input like this. And also, when I'm giving a value of 0 means everywhere I should apply this 0, right? Everywhere I should apply this 0. Let me try to take a copy of it. One second. Okay, fine. I taken a copy of it. So here I will explain what will happen whenever I am giving a 1 to it. So here by default I am applying a 0 to all the select lines so that everybody is now ready to select what called a R bar. I mean right shift it is going to perform. Let's see. So 0 means this multiplexer. So this will be connected to the output. Now what is this Q1? Q1 is this Q1, right? It's shown like that, but actually this kind of a connection is happening. Okay, so this Q1 I am taking and giving. So this is nothing but a direct connection, right? Something like this, that is going like this. So same thing is happening, our right shift circuit. Similarly, if you are looking at this, whenever this line is 0, this will be selected, and what is this? This is your Q2. This Q2 you have to connect like this. That is the meaning. As it is, it will be messy. They are showing like that. Okay. So this also in exam also you can do like this. So you don't have to connect like this. It will make the diagram very difficult to decode. Okay. So it's better to write like this. Okay. Similarly here also this Q3 will be selected. I mean that like this. So see, you can visualize that right shift operation, right? The right shift will happen whenever that control line is 0. It will simply shift the data towards right, because output of the previous flip-flop is being connected as input to the next one. So that is why that shift right is happening. Okay, and clock is applied simultaneously. Now let's see what will happen when I am giving a value of 1 to this. So a value of 1 to this means I want that load operation to happen, right? Sorry, not load, here L4 left shift should happen. So far by default what we studied is right shift. Now how this left shift will work? Simply you know this, right? So for a set of left shift means this is it should start from this this particular flip flop, and its output should be connected as input to this. Again its output should be connected as input to this, right? So that it will go from right to the left. This output should be connected as input to this. So this is a way. So am I achieving that on the background? Let's see. So whenever this line is having a value of 1, so this input 1 will be selected by all the multiplexers. So here it is the actual serial input, right? So this serial input is coming as output over here. Okay, now what about this? Okay, so I started applying the input from the rightmost end because I want to shift the data towards left. That is why I'm giving like this. Okay, now what will happen? The same thing will happen with this multiplexer also, and here it is 1, so that this will be connected in the output. Now just observe where is this Q4 coming from. This Q4 is this Q4, right? The output of this this particular flip flop where I started with, I am moving towards left, right, from the rightmost end. Similarly here also this will be selected, so this will happen, this kind of a bridging will happen. But from where this Q3 is coming? Q3 is coming from here. Okay, through the multiplexer it will go like that. Okay, so if you are simply, so this is something which can do both left shift and right shift. So if I am asking you to draw just the one which can do this left shift alone, then it is very easy. Just like this, just take say 1 2 3 4 multiplexer, and if you want to do the shifting towards left, it will be like so here you have to apply the input. So let me write like this, but in the diagram by default this is your D, this is your anyway I am writing like this for making this concept clear. Then this D, okay, and then this Q, again sorry, this is the Q and this is your D. Okay, and similarly this Q, this D. Okay, but normally, so this is your left shift operation, right? Typically the flip-flops the inputs will be connected in a slightly different way. That is what we need actually. So it is just like the same flip-flop, it's not good to chain the input and output, right? Instead you can chain the connection. So let me keep the input and output as usual in the standard way. This is your D, this is your Q, this is your D and this is your Q, this is your D and this is your Q, and this is your D and this is your Let it be like a Q4, Q3, some numbering I am giving, that's all. Q1. Okay, now what you want is actual serial input. So here serial input you are applying and serial output you are taking. So here this serial input should be applied here, and this output should be coming as input to this, and this output should be coming as input to this, and this output should be coming as input to this. The same thing, but I am implementing it in a slightly different way. The normal standard representation of flip-flop I am doing. So that is why that curling kind of a figure I am getting. So the same thing is happening here also. Similarly, next this one also, this Q2. So from where this Q2 is coming? Q2 is coming like this. Okay. So all will do like that. So as it is all about shifting, here in the diagram that outputting is not shown, so that you can further add, because that Q4 you can take as output for the right shift operation, and this Q1 you can take as the serial output of the left shift operation. So now this serial and serial output registers can do both left and right shift simultaneously using a single circuit. That this is what we are having. Okay, thanks for watching. This is again a slight variation, and these things are not explicitly given in your syllabus, so I hope it will be useful for you, or they may ask you this as a variation of this basic standard concept you are studying. Okay, that about it. Thank you.